are basis for R2 or R3. Justify your answer. So for to be a basis, this is plural, okay, to be a basis, the set should be, the vector should be linearly independent, and the vectors should span this the three components means R3, or when we have two components R2. So we have to have two things. And looking at these list of vectors, so let me erase this one. The first thing we want to check if the vectors are linearly independent. If we look at closely here, 8, -4, kind of half but negative, different sign. -6, 3 is half, different sign. So these two vectors are linearly dependent. So the answer for this one would be no. Okay, not a basis for, two components means R2, because the vectors are linearly dependent. When we have only two vectors, if one of them is constant multiple of another, then the vectors are linearly dependent, or linearly dependent set. It is clear. And C, okay, three components, that means the vectors are coming from R3, but there are 4 vectors. The number of vectors in this collection, in this set, is more than the entries. So this is a linearly dependent set. Okay, this is a linearly dependent set. Okay, so not a basis. In part A, we got two vectors, only two vectors. Then we can check linear independence or linear dependence. Okay, when we have only two vectors, we can check if one vector is constant multiple of another. 1 times 3 is 3, but -7 times 3 would be -20. So this is linearly independent set. Okay, that's good. But for a basis, we need two things: linear independence, and the set should span the corresponding space. Here we got three components. Okay, but these vectors are coming from R3. So these two vectors can't span R3. We need at least 3 vectors to span R3, because if we do the row reduction, we need 3 row pivots. Okay, 3 pivots, 3 pivot rows. And that's not possible, because when we have only 2 columns, the bottom will be always 0, 0. We can always make this 0, 0. Or anyways, when we have to do R3, we need at least 3 vectors to span. Okay, though this set is linearly independent, these vectors, only 2 vectors, can't span R3. Linearly independent set, but these two vectors can't span R3. We need at least 3 vectors to span, by the way, to span R3, because we need 3 pivot rows. Okay, so then the answer is what? No. Again, so let me erase this one. Not a basis. Not a basis for R3. Now D, so let's do over here R3, because we got 3 components and we got 3 vectors. Okay, they may or may not span R3. Though there are 3 vectors, these vectors can be linearly dependent, but we just can't see from here. So for this one, we need to do row reduction. We need to we need to form a corresponding matrix and do some row reduction. Okay, let's do that. So the corresponding matrix would be 0, 1, -2, 5, -7, 4, 6, 3, 5. Okay, the matrix only, not the augmented matrix, because colon something, we don't have that. So if we get 3 pivot columns, then the vectors are linearly independent. If we get 3 pivot rows, that means they span R3. And we need both linear independence and span R3 to be a basis. Okay, so we need pivot 1. Oh, here's 1. Let's swap R1 and R2. R1, R2, 1, -7, 3, 0, 5, 6, -2, 4, 5. Okay, now let's make this 0 using 1. I mean, the second row is fine. 1, pivot, 0, 0, pivot, which is 5, that's good. We need 0 here. So first make this 0. So R3, such that R3 -2 multiply R1 by 2. So 1, -7, 3, 0, 5, 6, 2, 2, 0, 2, -7, -14 plus 4, -10, 2 times 3 is 6, plus 5, 11. Okay, this is good. Now we need to make this -10, 0. Using 5 times 2. So R3 again. So R3 plus -10 means multiply R2 by 2, 2R2. 1, -7, 3, 0, 5, 6, 0, 0, 10 minus 10, 0, 6 times 2, 12, plus 11, 23. Okay, now we got pivot, pivot, pivot here. Okay, 3 pivot columns, 3 vectors, 3 pivot columns, so linearly independent set. And if we look at in this way, we got 1 pivot row, 2 pivot row, and here's also pivot, 3 pivot rows. That means they span R3. If we happen to have any ABC, any vector in R3, we can solve, we have a solution. Okay, span means if we have any numbers here, we can find a solution. So the answer is yes. Yes, these vectors form a basis. Okay, the vectors form a basis for R3 because they are linearly independent and they span R3. Linearly independent and span R3. Linearly independent because each column has a pivot. They span R3 because each row, because we need 3 rows, by the way, only 3 rows, and there are 3 rows with pivot. Okay, final.